A mechanical system usually referred to lift system, which an elevator. It is a device that moves people vertically between levels to levels. Although some pumps hydraulic fluid to elevate a cylindrical piston, like a jack, they are often powered by electric motors that drive traction cables and counterweight system like a hoist. The elevator is a machine that uses electrical energy, which has sporadic characteristics. The instant power of the elevator is more valuable when it is in use than when it is in standby, depending on the direction, duration, and weight of the load. These tools profile may change. In this report, we choose billions Seri Iskandar Perak as our case study. In this case study, we use electrical elevator. An electrical elevator is a type of elevator system that utilizes electric power to operate its various components. It relies on an electric motor and electrical system for the vertical movement of the elevator car within the building. It used for a variety of tasks, including raising and lowering objects, moving loads in the right direction, and moving people up and down stairs in multi-story structures.
For electric elevator system, the car is supported in a lift shaft by several steel hoist ropes, usually two shifts and a counterweight. The shift can grip the hoist rope and move and hold the car without slipping. Next, the machinery that drives the elevator is normally placed in a machine room directly above the elevator lift shaft. A gear machine has a faster motor and the drive shaft linked to the motor shaft via gears in a gearbox, which reduce the rotating speed of the motor shaft to a lower drive shaft speed. The gearless machine is powered by a slow speed motor, and the drive shaft is directly attached to the motor shaft. For electric elevator application, first is passenger transportation. Electric elevator move customer and guests between the most many floors. They enable easy access to several floors, making it possible for customers to move between business, restaurant, entertainment area, and other services. Second is good and service delivery, which is electric elevators make it easier to transfer items around the shopping mall. They transfer goods, supplies, and equipment between floors such as storage areas, loading docks, and retail locations. That is accessibility and inclusion. Shopping centers are public areas where people with various mobility needs must be accommodated. Access to all areas of the mall is made simple for those with impairment, parents pushing strollers, and elderly customers thanks to electric elevators.
For the installation process of electric elevator, the installation electric elevator involves a systematic and intricate process that ensures the safe and efficient operation of vertical transportation system in building. There are five installation process of electric elevator, which are firstly is planning and design, shaft construction, electrical and mechanical system installation, car and door installation, and lastly is testing and certification. For the planning and design, the installation process begins with careful planning and design. Architect, engineer, and elevator specialists collaborate to determine the appropriate type, capacity, and number of elevators required for the building. Factors such as a building height, expected passenger traffic, and space availability are considered during this phase. Second process is shaft construction. On the design is finalized, the construction of the elevator shaft begins. The shaft must be agreed to precise specification and dimension to accommodate the elevator system. This involves structural work, including the installation of support beam, wall, and floor. The shaft is constructed in accordance with safety standards and architectural plans, ensuring proper alignment and integrity. So, for third process, electrical and mechanical system installation. The electrical and mechanical system are crucial components of an electric elevator. Skilled technicians install the electrical wiring, control panels, and cable, counterweight, and safety devices are carefully installed and connected. These tests require expertise in electrical and mechanical engineering with adherence to industry standards and manufacturer guidelines. The fourth process is a car and door installation. The elevator car, including the wall, flooring, and ceiling, is installed within the shaft. The car is secured to guide rail and properly aligned for a smooth vertical movement. Door operator are fitted, ensuring safe and synchronized opening and closing. The installation of safety sensor and emergency communication device is also complete during this phase. And lastly, process is testing and certification. After the physical installation, rigorous testing is conducted to ensure the elevator system proper functioning and compliance with safety regulation. So, independent inspector or regulatory authority may conduct inspection and issue certification, confirming the elevator compliance and readiness of passenger use. Move to problem of electric elevator. Electric elevator have significantly improved vertical transportation in building and provide efficient and reliable means of moving people and goods. However, like any complex system, electric elevator also face certain challenges and issues that can impact their performance, safety, and functionality. And last problem is system reliability. The system reliability of elevator system is critical for passenger safety and satisfaction. Components such as motor, control system, and their mechanism may experience wear and tear over time, leading to potential malfunction or breakdown. Regular inspection, testing, and adherence to industry standard can help identify and address reliability issues. Additionally, manufacturer and maintenance provider play a vital role in delivering reliable elevator system and prompt resolution of technical problems.
There are various functions of electrical elevator. First of all is vertical transportation. The primary function of an electrical elevator is to transport people and goods vertically between different floors or level of a building. Second one is capacity and load handling. Electric elevators are designed to carry different loads, ranging from a few individuals to large amounts of goods. Last one is shorten the time to a certain floor. Time is efficiency. Electric elevators save time by quickly and efficiently moving passengers between floors.
Hello and Assalamualaikum. My name is Muhammad bin Abdul Hassani. So today I'm going to present about the principle of electrical lift. So an electrical lift is made up of a number of parts, including an elevator car, electric motor, a control panel, and a hoisting mechanism, also safety equipment. So the hoisting mechanism, which lifts the automobile between level, is powered by the motor. So the first is elevator car. The elevator car is the space or cabin used to move both people and things within the elevator shaft. It rises and falls vertically. So in order to allow passengers to enter and exit the vehicle at various floors, the car is often designed with doors on one or more sides. So next is the electric motor. It is used to raise and lower elevator cars. And in order for the elevator car to move up and down, the turning force generated by elevator motor is transferred to the rope winding drum. So there are three criteria must be taken into account in order to establish the power needed by an elevator motor for a particular installation, such as speed of elevator car, load to be hoisted, and the efficiency. So next is the control panel. It is the command center for running the elevator, and it has switches, buttons, and indicators. So to choose the desired destination floor, passenger will utilize the buttons within the elevator car or on each floor, and then these signals are taken in by the control panel. Then they are processed and used to start, stop, and position the elevator's floor. So hoisting mechanism. So the elevator car can move vertically thanks to the hoisting mechanism. It has a pulley system, a counterweight, and a system of ropes or belts among the other parts. And then the elevator car is raised or lowered by the pulley system, which is powered by an electric motor. So Billion Shopping Center use traction system for the lift hoisting mechanism. Lift with traction are an easy system. which a rope or cable is looped around a sheath to link a motor to it, and the rope is fastened to a counterweight at one end and the lift car at the other. The counterweight drops as the lift car rises, and vice versa. Because of the counterweight, the motor and entire system are put under less stress, requiring less power to raise or lower the lift vehicle. Next is the safety device. So to protect passengers, electrical lifts are outfitted with a number of safety features, such as include door sensors that prevent doors from closing if an impediment is detected, and then overspeed governors that active brakes if the vehicle exceeds a specified speed, and emergency brakes. So the guide grips and overspeed mechanism are attached to the bottom of elevator car with a small winding drum that is linked by a steel rope to the overspeed governor. And then the overspeed governor is set up with a grip so that if the elevator goes faster than usual, it will grab the governor rope and push the grips against the guide rails to stop the elevator car. If the power goes out or something else goes wrong, the emergency brakes stop the lift car safely and keep it from falling. Other than that, the lift also equipped with door sensors. So these sensors detect obstacles in the path of elevator door, such as objects or persons. If the sensors detect an obstruction, they prevent the doors from closing, ensuring the passenger is safe. So the next is space implications of electrical lift service. So for shaft design, to guarantee the construction of future-proper operation and safety, it must adhere to a number of requirements. So the number of floors, the size of the cars, and the required capacity all affect the shaft's design. And the shaft needs to be big enough to fit the elevator car and give enough room for maintenance workers to access it. And for machine room, the lift motor, control panel, and other electrical components are all kept in this room. So the kind and lift capacity determine the machine room size. However, the hose path of the elevator that is served by the traction elevator machine room is typically positioned right above it. So there are 5 building regulations of electrical lift service I want to point out. So first is the lift shaft design. The UBBL lays forth the specification for lift shaft designs, including their size, structural soundness, and material composition. It makes sure that the lift shafts have enough room for the lift car to move safely and to allow for maintenance access. Next is installation of elevator. All applicable norms and standards must be followed during the installation of electrical lift. Guidelines for installation are provided by the Lift and Escalator Safety Regulation 2010, which also specify the specifications for lift pits, lift machine rooms, and electrical wiring. Next is safety features. So to ensure passenger safety, electric lifts must be fitted with a number of safety features in accordance with the safety equipment such as overspeed governors, emergency brakes, door sensors, interlocks, and emergency communication system must meet this certain standards. Next is the maintenance and inspection. Regular maintenance and inspection are necessary to guarantee the safe and effective operation of electric elevators. The Lift and Escalator Safety Regulation 2010 has also specified the upkeep and routine inspection obligation for lift owners and operators. Inspections are conducted by authorized inspection organization that the Department of Occupational Safety and Health, which is DOSH, has established to make sure safety standards are being followed. So lastly is the accessibility. Malaysian building codes also include clauses that guarantee accessibility for people with disabilities. Electric lift accessibility criteria are outlined in the Malaysian Standard MS 1144, which is the code of practice for access for disabled person to buildings, which also specifies the size of the lift, braille or tactile buttons, audio signals, and signage. So there are 4 recommendations I would like to point out for the Billion Shopping Mall. First thing first is provide adequate number of lifts. The Billion Shopping Mall only have one lift, which can cause crowds and make people wait for a long time. As the number of shoppers and tourists grows, a single lift limited capacity can make it hard for people to get where they need to go, which can be frustrating and inconvenient. The best answer is to put money into adding more lifts to the mall. Do a full analysis of the mall's layout, traffic patterns, and peak hours to figure out how many lifts are needed. Next is clear signage. So, Billion Shopping Mall need to install legible and informative signage throughout the mall that directs visitor to the closest elevators and specifies the floors that each lift serves. To facilitate navigation, include for directories and directional arrows. Next is lift placement optimization. So the position of the lift need to be placed strategically in key areas of the mall to reduce walking distances and wait periods. Consider situation lift to close to entrance, high traffic areas, and popular stores to provide visitors with easy access. And lastly, accessibility upgrades. They need to ensure that the elevators comply with accessibility standards, including wider doors, braille or tactile buttons, audible signals, and accessible lift options. Implement the necessary innovation to make the mall accessible to all shoppers.
Hi, I'm Izana Atira. So, the benefits of electric elevators. The first one is energy efficiency. Electric elevators are known for their energy efficiency compared to hydraulic or traction elevators. They convert electrical energy into mechanical energy more efficiently, reducing energy consumption. Electric traction elevators demonstrated high energy efficiency when it consumes 75% less energy on average than hydraulic elevators. The second benefit is smooth and silent operation. Electric elevators offer a smoother and quieter ride experience. Electric motors provide precise control over the elevator's movement, resulting in smoother acceleration, deceleration, and leveling. This improves ride quality and enhances passenger comfort and also reduces the risk of motion sickness. It produces significantly lower noise levels compared to hydraulic elevators. And the third benefits of this type of elevators is space optimization, where it require less space for installation because it typically require a separate machine room to accommodate the hydraulic pump and reservoir. Whereas electric elevators can have a compact machine room or even be machine room-less designs. The space-saving advantages of electric MRL elevators allowing for more efficient utilization of building space. The next benefits is to increase speed and performance. Electric elevators are capable of achieving higher travel speeds compared to hydraulic elevators. Electric traction systems, such as gear or gearless machines, offer better control over acceleration and deceleration, enabling faster and more efficient vertical transportations because electric gearless elevators achieve higher travel speeds and shorter travel times. And the last benefit is this type of elevators can enhance safety. Electric elevators are equipped with advanced safety features to ensure passenger well-being, including redundant braking system, emergency power backup, and integrated monitoring system that detect abnormalities and automatically respond to critical situations. In conclusion, electric elevators offer numerous benefits and advancements in vertical transportation systems. They are known for their energy efficiency, smooth and silent operation, space optimization, increased speed and performance, and enhanced safety features. Electric elevators have proven to be more energy efficiency compared to hydraulic or traction elevators, resulting in reduced energy consumption. They provide a smoother and quieter ride experience, enhancing passenger comfort and reducing motion sickness. Electric elevators also require less space for installation, allowing for more efficient utilization of building space.
With higher travel speeds and shorter travel times, electric elevators offer improved performance and efficiency. Furthermore, they are equipped with advanced safety features to ensure passenger well-being, including redundant braking systems, emergency power backup, and integrated monitoring system. While, while electric elevators have their benefits, they also face challenges such as power outages, maintenance requirements, system reliability, accessibility, and the need for modernization. However, these challenges can be addressed through the implementation of emergency power backup systems, proactive maintenance practices, adherence to safety standards, technological advancements, and ongoing training and awareness programs. Overall, electric elevators have revolutionized vertical transportation in buildings, providing efficient, reliable, and safe means of moving people and goods. Continued assessment in technology and proactive management of challenges will further improve the performance and functionality of electric elevators, ensuring they remain a vital component of modern building infrastructure.